So now we're going to be looking at graphing polynomials. Now, what we looked at yesterday with our degree and leading coefficient to come up with a basic shape is going to be very helpful here. Here we have a negative leading coefficient and we have a cubic, which we know is a disco shape. So we should be starting from the upper left going to the lower right. Now it could just kind of continuously go down as you go to the right, or it could have a bump in the middle. It would not make a difference. We got to just figure that out. So we need to make a table of values. Now, when we were graphing parabolas and quadratics, we always started out at negative b over 2a for the middle of our table and chose numbers on each side. There's nothing like that that helps us here. So what we need to do is choose our table and choose it so that we get this basic shape down here. So you might start out with some values of x, and you might not get one of these shapes. That means you need to continue to expand your table in either direction so that you get that shape. So in this case, if we take and plug in all these values here into your function, and once again, you can have your calculator make your table and plot your points, you would get this. So if we are estimating our zeros, there's a couple ways you can estimate your zeros. You can see you cross right here at 1. Now that shows up over here because we get an output of 0. So we know we're at a height of 0, and that's really what we're looking at. We can also see that we are crossing between 1 and negative 2, not exactly at a nice neat number, but we can see that here. We can see at negative 2 we're below the axes on our table, and at negative 1 we're above the axes. When you go from below to above, we have to cross in between those two. And then you can also see that it crosses somewhere between negative 3 and negative 4, and that shows up on our table because you go from positive to negative for your y value, so you get a cross in between those two x values. So what we're going to do for our answers for estimating our zeros is we're going to write down between negative 3 and negative 4. That would be the red ones, or what we had right here. And then also between our two purple ones, or these two, in between these two right here. And then we don't have to estimate this one. It is actually right at 1 because we can see when we plug in 1, we get out 0. So see if you can go ahead and do that on this one here. Now, based on your leading coefficient and your degree, you know it's going to be a touchdown going up on each side. Now, you need to make yourself a table so that you end up going way up on each side. So in this case, I made this table, plugging it in, and then we can plot those points. When you plot those points, you get this basic shape. Once again, your table or your zeros show up when you switch from positive to negative, so it would be between these two, which shows up right here, between here and here. Then your other 0 shows up when you switch from below to positive, which goes from here to here, which shows up from 2 to 3 in between those two. So that's what we would write down for our answers. Now, your degree tells you how many, the maximum number of zeros you could have. We could have 4 zeros, but not necessarily. If we had slid this whole graph down some, we could have had 4 zeros, but the graph as it is only crosses your x-axis twice. Now, you're also going to be asked to find your local min or local max, which is a maximum only in that neighborhood or small area of your graph. Here, your relative min or global or local min is a min only in this small area of your graph. Your absolute or global max is the highest of the whole entire function, not just the region. Or your global min or absolute min would be the minimum of that whole entire graph, not just that neighborhood or area. So On this graph, we need to graph it. We need to estimate our zeros. We need to then look at the x-coordinates of our max and our mins. So looking at this, it's an odd degree, positive leading coefficient. We know it's going to have to be one of our disco shapes. So we choose for values for x, and we plug them in. And we got to make sure we keep choosing our table, making it big enough, sometimes by trial and error, so that we get that shape. We know we have to be going down on the left, so that means when we go off this way, we got to be a big negative, which we are. And then when we go to the other side, we have to be going up. So when we plug a number in, we got to get out a big positive, which we are. So we know we can look at our table and get that shape. We plot those points and we get this basic shape, which does match with what we were anticipating. We now need to estimate our zeros. Well, we don't have to estimate one of them because one of them is exactly what it is we're looking for right here, because we get an output of 0. But then we know we have one right here because we're going from positive to negative, so in between these two. Also, we're going from negative to positive here, so we have one in between these two. So what we have there on the left will match our answers. By the way, we have in between these two, and exactly right here, if you look at your graph. So I'll put those down exactly at -1, in between 1 and 2, and in between 3 and 4. Now you're also asked to estimate your x-coordinates of your max and your min. Now this graph does go up forever, so it would not have a global or absolute maximum, but we do have a maximum just in this area or neighborhood, and that occurs when x is 0. And you can see your biggest number right in this area is 5, and that occurs when x is 0 for your max. Looking at your minimum, while it goes down forever, so there is no global or absolute max or minimum, but there is a small trough or bottom point right here, so we do have a minimum just in this local area. Now, it kind of, what you want to do, because it doesn't end up being at a nice neat number, what I would do is I would look at the smallest number I have over here, which is -4, and then choose the corresponding value of x. Could we get more precise by looking at all the decimals in between 3 and 4? Yes. But just look at your whole number inputs and what you get out. Look at the smallest number that you get out, which is -4, and look at the corresponding input. That's what I would do for this.